Hello everyone, this is Luboš Pirkl from CFD Support, and I would like to welcome you to the next webinar where we would like to show you the new TCAE version. It's a big day today at CFD Support because another big cycle of developments and fighting various difficulties. We have created and tested. It's important, a new package, the new version of TCAE, and in today's webinar we would like to show it to you and really show it to everyone who is interested. So welcome. Make yourself comfortable and think about what it is, what you need in your simulations, in your engineering processes, and how you would like to maybe improve or your engineering, and how we can help with that. Yeah, the webinar is being recorded, and the recording will be made later publicly available on our YouTube channel. So there will be a recording. In the first part, I will again say what's necessary about basically the general information about us and what's on the table. In the second part, my colleague Radek will show a little bit technical hands-on experience with the new version. And in the last part, if there will be any questions, we will be happy to answer your questions. So feel free to ask your questions anytime during the webinar. The most representative and relevant questions will be answered right away in the webinar. Specific questions will be answered later via email, but you can be sure that all questions will be answered. It's our pleasure, it's our job, and it's our great happiness to answer all the questions. So let's make a quick check if our colleague Radek is here with us. So knock knock, Radek, can you hear us? Can you see us?
Yes, hello, I can see you, I can hear you, and welcome all the attendees.
Okay, Radek, great to have you here, and I think we can start the presentation. I suggest we would close the cameras, and hopefully we will come back later. So let's switch the cameras off. Yeah. Okay, I believe there's a better portion of information in terms of aspect ratio of the video. Okay, so yeah, the new version is here. Typically we release 2 versions a year, so this is the later one in the year 2024. So yeah, again, we have spent enormous time and enormous effort to put everything together. It's really not easy to create and develop, test and sell and maintain the software. Believe me, we do it for last almost 15 years, and it's really a big challenge. So if you ever have an idea to start your own business with creating software, I would recommend you think twice and actually don't do that. It's a really complex thing. Anyway, I'm joking here. I would like to invite you for a couple of new webinars still this year. Next week we will show our complex workflow on acoustic simulations on airfoils. Still in November there will be a wind turbine CFD, FEA and FSI and optimization webinar, and the last webinar of this year will be about pump, a benchmark we did like 2 years ago. And so yeah, internal flow pump and yeah, blood flow in December. Okay, so those are the webinars. I'll start with who we are. So we are company CFD Support. We are located in Prague, Czech Republic, and we are on the market for 15 years now. We deal with CFD, FEA, and FSI optimization and acoustics, so basically the engineering simulations. We do all the wide range of services for that, but the most important part of what we do is developing software called TCAE, and in today's webinar we are going to introduce its new version. So yeah, our flagship product is TCAE, which is a comprehensive simulation environment where the engineers can simulate a wide range of engineering problems connected to fluid flows and their flow properties and fluid dynamics, of course. TCAE consists of software modules, and it's extremely flexible, and engineers can play kind of puzzle with them. So they can use individual software modules to employ them in a chain or in a process of simulations. The really good news is TCAE is extremely flexible. It can be integrated to an existing processes, or it can create completely new processes. It can be combined and connected to other software pieces like in-house codes, commercial codes, other open source pieces, and really it's very flexible. That's the point number one. We believe it's a big value in today's dynamic world to have flexible tool to create flexible workflows, which completely go well together with your skills, knowledge, experience, goals, of course, and potential results and the level of results you want to achieve. TCAE is unlimited in the number of its users, job scores, hardware installations. So users can use their resources to the fullest. That's really important feature of it. There's wide range of collaboration options. We are also very flexible in that. TCAE is based on open source. It's extremely important. So it's based on open source. So the simulation is built up on existing open source software pieces like OpenFOAM, ParaView, Calculix, NetGen, OpenVSP, etc., etc. And altogether, there is more than 60 open source projects in TCAE, and it itself it's a huge value. And we here at CFD Support, we have mastered the process of acquiring the open source and making it available for wide range of use in the industry. So put everything together to connect the software and create a comprehensive package out of it is relatively a complex task. And on top of those open sources, we have spent more than 50 many years aggregated in development of these tools. So the value the users receive is really it's huge. Basically, if you imagine how much work has been and effort and time has been spent on OpenFOAM, on ParaView, on Calculix, and all the other open source pieces, and on top of that, plus 50 many years of development has been spent on this software. So for your imagination, how much work has been spent, it's enormous, and this is what you receive with the software. TCAE is focused on turbomachinery applications and on external aerodynamics. That's really important. It's not software for everything. It's specifically really good. It has great performance on turbomachinery applications and external aerodynamics. It's well automated, so it can be run as a black box basically, or it can be used as a fully sophisticated high-end software. It's always up to the user, and it's the part of its flexibility, as I mentioned. It has wide range of usage regarding the remote computing. It can be used on laptop, desktop, PC, cluster cloud. It can be used remotely from home or from work or on the computer you sit at. It's really there's a really wide range of usage. It's compiled for Windows and for Linux, the same workflow. It can be run in the graphical interface, or it can be run on cluster in batch mode. So all the options are open in this terms, and the workflow is consistent and same on every operating system. There are over the years we have gathered. Of course, we continuously running benchmarks. So we have 15 public benchmarks, which here I mean the particular cases with the comparison of the CFD of TCAE results with the measurements or with the analytical solutions. So we have 15 benchmarks where the users can make sure how everything was done. They're public. Everything is publicly available, and the cases are transparent, and they can be rerun anytime. So it's very transparent in these terms. Plus, there are 50 tutorials which are based on real projects we did in the past. We only changed a few details, not to be recognizable where they come from, but there are 50 tutorials or real of real industrial machines, I would say. And also we have, I would say, a really good technical support, and we deal with every issue that we are asked. There are a couple of directions in the future we will definitely deal with. One of them is the optimization. So we have the optimization module, and for the future we will continue developing it because we believe that the optimization is really important and really brings certain value to users who have the product and want to make it better. Second important cornerstone of our development is the acoustics. So we keep developing the acoustics module. We are doing really well and very intensively, and we are getting better and better almost on daily basis. So the acoustics module is getting better and better. And also we believe that in the future, those who have the data will have, I would say, a large advantage. And we believe in surrogate models, and we are developing a new software module called T-Base, which will allow users to create their own surrogate models. And we believe it's again a huge, I would say, paradigm shift in the simulations. So another cornerstone is a new software module called T-Base. So that's the future, but what we have now here is this. So now I am going more in detail with what's on the table at the moment. So we are yesterday or today and this week we are releasing the new TCAE, which is the version 24.10. And if I should say quickly in general, so there are a couple of important news. So first of all, there's a new light version. We call it TCAE Lite. It's primarily designed for individuals. I will talk about it a little bit later. We have resolved more than 100 bugs in the software. Yes, it happens because there is, as I mentioned before, there's more than 60 open source codes and our development and a lot of libraries and applications and everything and scripts. So yes, the bugs happen, and we resolved more than 100 of them. So it's really a lot. So even for those who are happy with previous version of TCAE, we would strongly recommend to update to the latest one. In typical contract, we don't ask for any additional money for that. So update as soon as possible, because we believe that there are improvements for everyone. We have improved more than 40 internal processes and features which are difficult to explain. So it's just a number, but we improved really a lot of things. We believe TCAE is again the way better than it was ever before. That's really important. There are two new tutorials. It's the Formula 1 and the supersonic ballet aerodynamics. So we can talk about them, and we will talk about them later in time. Just follow us and follow our website and everything and social media, and there will be case studies. And we have updated the open source packages. For example, there's new ParaView 5.12, I guess, version. and etc. etc. So there are a lot of updates, even if the new features, which we will talk about them a little bit later in this webinar, Radek, I guess, will introduce the new features. There are still a lot of new things which are not directly visible. So again, I would like, because I know in this webinar a lot of our clients are following, so I would like to kindly ask all our clients to switch to the latest version as soon as possible, because it really makes sense, and for us it's also easier to maintain and provide technical support to the latest version, and it's really really the best what we have done. So there are also new features. I will skip this part. My colleague Radek will talk about it a little bit later. I will say one last point in this part, and it's this. It's together with TCAE, we are launching the new product. It's called TCAE Lite. It's primarily designed for individuals, and the intention is to make this technology, because we believe it's unique technology, to make it accessible to everyone. We simply want to have this technology to allow as many users as possible to use it. And for the historical reasons, we deal with open source, and a lot of people come to us who have very limited budgets and ask us what we can do for them. So this is the answer. This is the answer to all those who are coming and are, I would say, a little bit short in budgets. This is the answer. It's TCAE Lite. That it's still technologically developed perfectly. It has. I will talk about it, and it doesn't cost much at all, I would say. So TCAE Lite, it has it's a separate product. It's standalone. It's different installation, different everything, and it's a little bit green. Maybe you can see it. The interface is a little bit like greenish. You know, you can for the first sight you can see it, while the full-blooded TCAE is gray or blue gray dark. This is a little bit, there's a certain amount of green to distinguish quickly, recognize what's on the table. And a little bit about TCAE Lite. So it's a simplified version of TCAE, but the good news is it has all the features as TCAE. There are no limitations. There are no hidden limitations or anything. It only has two software modules, TMesh and TCFD. This is really important, so I'll repeat it. So there are two software modules, TMesh and TCFD, and there are no limitations or no hidden problems. It's really these two software modules. Only our responsibility for everything is a little bit, I would say, decreased. So the technical support is provided via online forum. So if anyone has any problem with it, just go to forum, ask there. We will help. Of course, if we like, but our commitment to technical support is a little bit weaker than at full-blooded TCAE, which is designed for organizations, but TCAE Lite is designed for individuals who have more time but less money or lower budget. If I hope this is clear. So the technical support is provided via caeforum.online. The simulation template, as you know, in TCAE, there are a lot of templates like pump, compressor, wind turbine, hydro turbine, etc., etc. So there's only one simulation template, but it only talks about the formulas that are used for the evaluation of the results and for the report. So this weakness of TCAE Lite it's not a weakness. All features are still there, but the report is a little bit shorter. For the future, we will develop this new general template as a general GUI for OpenFOAM. So yes, TCAE will over the time become a GUI for OpenFOAM. So we will extend the features of of the GUI to mimic perfectly the current development of OpenFOAM. So TCAE Lite is going to become a full graphical interface for running OpenFOAM simulations. We are there. We are on the way. We have several solvers, I would say, and they work. It's perfect. But over the time, we will make it more and more OpenFOAM, if you know what I mean, and it's easy to show it on an example. And yes, TCAE will cost 30 euros a month for every individual, and we believe it's a price which is good enough for all the individuals, and it's basically price of your it's a cost of your daily cup of coffee. So if we hope it's fair for everyone, and that's what we made up. And now I would like to hand over the presentation to Radek, and he will say a little bit about the new features. Hello,
Yes.
Radek.
Yes, just if you can hand me the presentation.
I will. Sure. Yes, I was too passive in the beginning, but I'm going for that. So yes,
so I'm taking
now
the screen.
we can see your screen and we can see your presentation. Radek, go ahead.
Okay, perfect. Thank you. So my part is to present the main new features in the brand new shiny version of TCAE. So I created a presentation which sums up the main new features we have developed, which are directly visible for the user. But as Luboš already mentioned, there are dozens, maybe more than 100 updates and bug fixes and features improvement which we made together over the last half a year. Okay, so let's go to each part or each new feature. So let me start one by one. So first one is we reduced the ports, which you can see in the pipeline browser. There was first modification was to get rid of this settings item, which basically is holding the menus and all the setup parameters. So now it's reduced that each module, the headline of the module, stores the data. So this improvement was made. So let me show it live. So I will borrow this pipe tutorial, which is directly delivered within the installation. So easy test case on which you can directly test if the installation is okay, if your license is valid, etc. So as you can see, there is no settings anymore item. So directly it's the same like in previous versions. So still the first item of the module holds the menus. So this was significantly reduced, and let's say make the GUI and pipeline browser more clear and more readable. So in this, you don't need to be scared that the settings are out. Still the same menus, same structure is there, but the first item always holds the properties of each module. Right, so pipeline browser, it was quick. Then connecting with this pipeline browser, we redesigned the results visualizations. So it was somehow cut off of our standard workflow. So now each module has its own results port, using which you can visualize the data. So directly the results visualization are now connected to the given module. So it's not visualized apart as for the previous version, but directly is within the given module. So again, if I can go back here, so here I have a already computed case, and if I would like to visualize, for example, CFD data, so I can, for example, open new render view. I can go to the manager, and here, for example, in the TCFD module run, here we have new section results, and here you can click display new results. In case of you have, for example, stationary and transient result, then there will be a new menu using which you can click on which results you would like to visualize, if stationary or transient. So here we have just the transient, so I can click apply, and now you can see that there is new item pinned to the results port and here you can again go through the results of the simulation. So so it's in the standard way, but now it's nicely fixed into the TCFD module. And for example, if I would like to also add the FEA results, so I can go back to manager, to the manager, expand the TFEA run, again display new. Now, because I have 3 points, so I have 3 results for FEA analysis, and I can visualize, for example, the last point. So I would like to visualize the 3rd point for the FEA, apply again, and now, as you can see, I can for example, visualize the von Mises stresses. And if I would like to also see the results for the 1st point, so again, I can go back, display new. So now I would like to see the 1st point, again, apply. And as you can see here, I have new port here with the new result for the 1st point of FEA analysis. And again, I can watch the results. And all the time I have nice overview of what is visualized for each modules. I can get rid of some unwanted results. And in this way, I can nicely combine. And even though I can directly switch to, so it will be directly visualized, or I can click by standardly on this eye icon next to the results item. All right, so this is pretty new feature, and I think more friendly, and it makes the workflow more easy and smooth and understandable. So this was about the results visualization. Yeah, so here's some kind of sketch. So if, for example, yeah, you have also transient run and you click on the display, then you will see this menu where you just choose which type of the results you would like to see, if stationary or transient, and particularly which point from the transient run. And everything what is visualized is nicely depicted in this table. So I think it's more clear and more user-friendly visualization. And of course, concerning the results management is more clear. Okay, so this was about the ports. Then about the client server improvement, there were many hidden features which we have developed and somehow functionalities. And one of the new functionality is that if you creating new project on the remote server, for example, but you have no data on the remote server, so now if you are importing any data, so typically for the T-mesh module or the initial or inlet condition for TCFD or surface data for the acoustic analysis, for example, which we will be talking later on. So then in the importing menu section or in this window, you can distinguish where you would like to take the data, if on the local file system, which means on the system on which you are running this the client, or if you would like to take the data on the remote server. So typically I will connect to the remote server, but I have the data prepared on my local machine, so I can click here on the local file system, and this data will be imported and sent to the remote file or remote server, and the data will be imported there and stored within the project there. I'm not if I'm any running server, so let me try it. So I will open new session, and I'm not sure if I have run a server on my computer next door in the office. So let me try. So I will connect. Where is the icon to connection here? So I will create. I would like to connect. Okay, maybe I have some running session on from another computer, but let me test it. So I try to connect to my client. Okay, it's not working because I think the remote server was shut off. Never mind. So I think the descriptions were nicely done here. So basically, if you click here, you will see such menus here, and then you can distinguish from which side you would like to take the data, if on the remote side, remote server, or from the local machine. Okay, the next feature is that we add some additional simulation controls options. So we add the solver minimum and maximum iterations, which is connected to the maximum and minimum iteration of the linear solver for each quantity. So this is useful, for example, when we are playing a lot with respect to the acoustics. We are playing a lot with the transient solvers with really small time stepping because of resolving all the frequencies. And the thing is about the tolerances. So if you have really small time stepping, then the tolerances has to be decreased sometimes. Otherwise, for example, for some quantities like turbulent or temperature quantities, there is the absolute tolerance is satisfied because of small time stepping. So then the solver do, for example, zero iteration, and the solution doesn't change anymore. So this is some kind of safe some kind of safe guide which keeps the solution robust even for wider range of application and time stepping. So now these tolerances, these max minimum iterations, are automatically applied to all the quantities. And for example, the default one is pretty okay, but you can also play for some specific application. You can decrease or increase the maximum iterations to lower or to increase the accuracy or robustness of the simulation. Yeah, so basically, if you go to the TCFD simulation control section, which is here, and here you have these two options. So you can play with it, and this can be also changed runtime, so you can play also during the simulation how it affects the solution and the simulation itself. Okay, so this was about the simulation control options. Then we implemented new initial conditions mode. So for the previous versions, if you would like to, for example, initialize the new simulation within with some existing and or previous project results on the same topology of the mesh, then there was only one option to use mapping. So in general, mapping has to be used on initializing the cases from another one which has not consistent meshing. So basically the mesh parameters are different from the current one you are going to simulate. But we have a lot of cases where we playing with the same meshing, but we need to, for example, add more simulating points or play with some another CFD parameters. So we are not playing with the mesh itself. So we have developed new type of initialization, which we called copied. So it directly takes the data from already simulated case with the same meshing parameters, and these data are directly copied or imported and are used as an initial condition for next simulation of the new project, which really save a lot of troubles because the mapping is not so robust, the mapping feature. But this copied case is pretty quick and robust, and it makes the process much faster for the cases where you are just playing with different parameters, but we are not playing with the meshing. If you look into the GUI, how it works, so for example, I can open, let me open a new session. I will create a new case. Okay, well, here I have a new session. So let me create new from the existing one. So I will take this pipe. So now I'm creating new project which is created by the setup of the existing one. So this piping. And for example, now I will change the boundary conditions on the inlet. So I would like to compute higher flow rates, for example. So I have higher flow rates. And now to speed up, I would like to initialize it by already existing results. So I can choose here copy it. I can import new results. So I will choose the existing project. We'll click OK. And now, because I have 3 results, so I can choose which result will be taken as the will be taken and used to initialize this new project, new simulation. So I will take the last one with the highest flow rate. Okay. So now the initial conditions are okay, are imported, and yeah. And whenever you then start new simulation, then it will use the data to initialize. And basically, if I take the last one, so this value will be basically used as the initial conditions to simulate the next project. So this is about the initialization. And if I go next, now there are really heavy development of the acoustic module and the features around the acoustic module and about the storage, the acoustic data. So let me now go through these points. So I will take new projects. I will close this one, and I will load a project for the acoustic analysis, and I directly take the project which we will be presenting next week. Yeah, the acoustic of the NACA profile. So basically, we will be talking about this benchmark and about the acoustic module in more detail next week in the next webinar. But now I would like to just present the new features which we have developed. So just to quickly introduce this case, I will make the opacity. So we have a NACA profile for which we would like to measure the acoustic. So we have a preset meshing, of course, CFD simulation, and acoustic module. And now let's go step by step over new features. So first feature is that we added a possibility to add the permeable surfaces. What does it mean? In default, you can measure, or you can, in general, the acoustic model is based on the acoustic. Now I lost the word. On this William Fogg Hawkins acoustic analogy, I found it on the acoustic analogy. So for the acoustic analogy, we need to store the pressure, density, and other field fluctuation on a reference surface, and then these pressure fluctuations are taken to do the acoustic analogy. So propagate any source from the surface to the observer and build the acoustic signal. So in default, what you can take as the source surface is the patches itself. So if you go to the TCFD simulation and runtime evaluated quantities, and here is the section to write acoustic data. So here you can we have, in the previous version, we have the CFD patches. So on the chosen CFD patches, the acoustic data were stored. And now the new feature is that you can even add, there are 2 new features basically, 2 in one, is that you can add more surfaces, more acoustic surfaces, which is really important because typically for acoustic simulation, the CFD simulation takes a lot of time. So it's simulation for weeks, depending on of course on the case and the mesh resolution, but it's really demanding. And so you would like to store as many data for the later acoustic analogy, because then you can you store the data, and then you can make the analogies from the different surfaces and play around. So therefore we have several surfaces, so you can store directly within the single simulation that data on the CFD patches, or you can store it on the external STL. So basically the external STLs, you create a shape which somehow intersects your flow domain in a proper place and with the proper shape, and then you simply import. So here we have an example, I think here in the STL permeable surface. So you directly import it, and you see, for example, this is the permeable surfaces, which will be also used to store the acoustic data on it. So these basically are two features in one, so permeable surfaces and multiple acoustic sources. So which is basically what I have shown now. So many surfaces as you want, and you have two options, patches and external STLs, which can serve as permeable surface, so some surface within the flow domain. Again, basically there are three features in one: improved acoustic data storage. So with this, you also can choose the format of the acoustic data. So originally we have just simply some kind of foam data format, ASCII or binary, but because within a, for example, typical simulation of this NACA profile, or for example fun benchmarks, you store a lot of data. So you can imagine that every time step, and the time step is very small, and you need to store, for example, 2 revolutions of the fun, and so you have a lot of data to be stored every time step, and there could be, I don't know, thousands of time steps. So typically you have the terabytes of data. So any storage, any saving of disk space counts. So we have developed this foam binary tar, which directly stores and compress the data and store them runtime. So this compressed data now saves a lot of space on the disk. So this can be now also be chosen as a format of storing the acoustic data. Right, so these three features were directly connected to the storing the acoustic data, and now we have some kind of evaluation of the acoustics. So now if we go to the TCAE module, so we have source frequency analysis. So we can do the frequency analysis directly on the sources on the surface or on the permeable surface. Typically, it is done on the, for example, for the airflow like simulations. So we would like to see the phase, for example, of the acoustic source signal, and from there it can be somehow you can analyze how many sources it makes, or how they are amplified or reduced together. So here you ask in the source surface analysis, you ask for creating this pressure fluctuation analysis, and as a result, I have an example here. So if I open the data, so within the computer project you will find it, but I have exported here to have it here. So you have such kind of data depending on how you define the source for the acoustic data storage. So here I can take, for example, the suction or pressure suction side FFT. So I can open this file, click apply, and if I am correct, so I can visualize the cosinus phase of the source signal, and here you have the data for different frequencies you have chosen. So for example, this is the source data for the frequency 1000 and the phase of the source signal. So you can nicely see for which frequency and how, for example, the saturation affects these phases, etc. So this is nice feature to be visualized and to be computed within the new version of TCAE. And maybe what I have lost, what I forgot to add here, is that we have, maybe it's not so important, but it's a little bit hidden, but also important to some advanced analysis, that in the CAE analysis to the source acoustic data, so you can apply some kind of geometry constraints, so you can cut off any part of your source surface, for example, to see what kind of acoustics will be generated just from the part of the surface. So which is also very important, a nice feature for deeper analysis, or you can focus just on the trailing edge typically for this kind of simulation. So you can cut off any area and just keep the trailing edge part with the serration and just analyze how many acoustics or noise is generated by just this part of the geometry. So for this feature, for this purposes, this feature applied geometry constraints can be used. And last but not least, we also parallelize this acoustic analysis. So if you can imagine that any point on the source surface create the noise, is the source for the acoustics, and all these signals, these points has to be managed and processed. So this processing, this acoustic analogy is now done in parallel. So you can set as many cores you have to parallelize this process, and it very speed up the acoustic analysis simulation itself. So when we started, for example, for the NACA profile, it takes almost 1 day to process large data sets. And now, if, for example, on my computer, on our cluster where we have 32 cores, now we are going up to several dozens of minutes instead of 1 day of simulation. All right, and I think I'm almost at the end about the main features. So I think it's time to go back to Lubos and continue with our webinar. So Lubos, are you there?
Yes.
Okay, perfect.
yeah. I'm a little bit
not
of silence, but I wanted to test you. No. Radek, thank you very much. We are there. Thank you for the for all the features that you showed us. And let's go ahead with the webinar.
So feel free to take the presentation, which you maybe already did, right?
I guess I did.
Okay, perfect.
Okay, so I hope.
Yes, I can see it. Nice.
Okay, so yeah, so let's go ahead. So I would like to ask the audience to ask your questions, because we are approaching the Q&A session where you can ask your questions and we'll be happy to answer them. At this place, I used to say that, okay, this is a quote that technology is only 40% of success. The rest is the effort. So how much time, how much skills, experience, patience, and dedication you put in. So this is something which I like to say all the time. You can. The software is just a tool, right? But what you make with it is the final result is definitely much more complex than just the effect of just software. It's also what we put in it is extremely important. This is what I wanted to say, and I'll rather go to Q&A. So yes, please ask your questions. I can see quite a lot of people in the audience, so ask your questions and we'll be happy to answer them. Okay. Yes, I see a couple of questions about the TCAE Lite, because yeah, it's obvious it's a new product and people ask about it. So Frank is asking whether it's possible to run what cases in it. So this definitely deserves a wider explanation. So during the Radek's talk, I worked here a little bit. I ran the tutorial, which is part of TCAE Lite. So the Lite version has this tutorial, which is Formula One, simple model. The default settings is very rough mesh to run on every computer, on like on laptops. So the very rough small mesh. And the point is, you can run anything what you can run in TCAE. You can also run in TCAE Lite. We made this effort to smoothly convert everything automatically. So the question, the Frank was asking, I have the question in my email. He asked whether he can run compressors in TCAE Lite. Yes, you can run anything what you can run in standard TCAE. You can run also in TCAE Lite. The only difference is the report. So the report in TCAE Lite is a little bit shorter because it's a general interface which will be later dedicated to open form simulations and will be further developed. But anything what you can run in TCAE, and the examples you can find on our website. I guess you know where there is the menu section case studies, and you can see quite a lot of you can see quite a lot of case studies. We have 50 of them of the real case studies which we ran in the past, as I mentioned. And you can run them in TCAE Lite. You can download them and run them in TCAE Lite as well. So regarding the CFD part, you can run it everywhere, and vice versa. So if you open the same case, which I did here during the Radek's talk, if you open the case in standard TCAE, which is now, you can see the gray background and everything. You can run it again. So the CFD cases are 100% compatible with everything. So we had another question about the releasing of new versions. We created a system that the TCAE and TCAE Lite, they are developed together. We have one development structure. That's really important. So we have one special development environment, which develops where we developed both packages, and they will be compatible forever. And while the TCAE Lite, this green interface, will be more and more becoming the open foam graphical interface. TCAE will keep its industrial and organization focus, but it will always be able to through the simulation types, it will be able to open the cases from TCAE Lite. So it's the compatibility is 100% both sides. That's my answer on this. And what else? It's this question. Daniel is asking, is mapping of results to an external mesh possible without recalculation as a separate option? And is it parallelized? Radek, could you go for this one?
We haven't touched this feature, so this feature is the same like for the previous version. So I think Daniel is speaking about the mapping the CFD results onto the external tool, like this, or onto the FEA part. I'm not sure about the question, but I think if we are speaking about the mapping of these kind of results, so then we haven't touched this feature. So I think it's the same.
When you map to somewhere else, it's everything is the same, and the initial conditions mapping, as what Radek mentioned, the new feature is between the cases inside TCAE.
Yes.
And also that there are relatively strong requirements on the same mesh. So I would like not to promise more than we can deliver, and this feature is really efficient, but only for specific workflows, specific cases. This is not something which is generally general impact on all the cases for sure. So it's only a small feature of this kind. Okay, what else we have here? I have to say I can't see any more relevant questions. So let's make it let's make it easy. So let's go ahead. Feel free to come back anytime. Your questions and I really mean it. It's not a joke. They are important to us because we committed ourselves to make this software the best software possible. So yeah, feel free to come back anytime. We will be happy to help. We talk to everyone who asks, and it's one of our important, I would say, DNA coded features. So we talk to everyone. Feel free to ask, and we will talk. And this could be it for today. So yeah, we would like to thank you for your attention. We would like to wish you all the best with the new software and with on your engineering simulation journey. And let's keep in touch. And thank you, everyone. Bye bye.
Thank you and bye bye.
Bye bye.